This is lesson 4, and this is all to do with electrostatic shocks that you might get from the trampoline, or from having bounced on the trampoline and then touching something metal afterwards. So you can see in this wee diagram here that the man here has picked up some static charge as he's been walking around or whatever, and he's gone to touch a metal doorknob, and as a result there's been a static charge passing from his finger to the doorknob, and the result of that is he's going to feel a shock in his finger, which isn't going to be very pleasant. So we're going to just have a wee look at what causes static electricity and why some objects will become statically charged but others won't. So the first wee bit we need to look at is the structure of an atom. And you should have an idea from chemistry that the structure of an atom is that in the middle part of an atom you have a nucleus, and in the nucleus you have two different kinds of particles, and they're called protons and neutrons. Outside, in what we call rings or shells, you have electrons which are moving around or orbiting. So in the middle of each atom is what we call nucleus. The nucleus contains two kinds of tiny particles, and those two kinds of particles are called protons and neutrons. Orbiting around the nucleus are even smaller particles, and those particles are called electrons. Now, we will refer back to this wee diagram again in a minute when we're talking about electrons and protons in particular. Now, we can liken the structure of an atom to the solar system. I'm just going to scan in a wee bit and hope that you can see this writing a little bit better. This is from your notes, so you should recognise it. Okay, so we're going to try and talk about, these are some statements associated with the solar system. So the sun is very large compared to the size of the planets. The planets orbit the sun. Planets are very far away from the sun, millions of solar systems in the universe, and the sun at the centre of the solar system. So we'll start with the bottom one here, the sun at the centre of the solar system. And you can see up on this side we've got the nucleus at the centre of the atom, millions of atoms in the material, electrons very small compared to the size of the nucleus. Electrons are very far away from the nucleus, and electrons orbit the nucleus. So sun at the centre of the solar system, and the nucleus at the centre of an atom, and they are, I'll just scan out a little bit so you can see the whole thing, they are connected to each other. So the next one here will do millions of solar systems in the universe, and again I'll just make it a wee bit bigger, and you can see there are millions of atoms in a material, so those two are going to go together. Next one then, planets are very far away from the sun, and you can see over here we've got electrons are very far away from the nucleus. Next one, the planets orbit the sun, and we have electrons orbiting the nucleus, so we're going to draw a line down to the bottom here. And one left then, the sun is very large compared to the size of the planets, and electrons are very small compared to the size of the nucleus, so they're really, really tiny, and therefore we're going to put an arrow down there. So we call this as an analogy. It means it's similar to that we can relate one thing, one property of the atom to a property of the solar system. That's what an analogy is, and it's very good to use those sometimes to help you understand things, and in this case it's about the structure of an atom. Right, so we're going to talk about neutral atoms and then charged atoms. So there's your structure again. You've got your nucleus with protons and neutrons and electrons around the outside. Protons and electrons are charged. Protons have what we call, and you can see a little plus sign here, so they have a positive charge. And then electrons have, and I'm going to write a little minus there, a negative charge. Neutrons have no charge, so neutrons are also found in the nucleus. They are, we say, neutral, and that's where their name comes from, neutrons, like the word neutral. You should always remember that. Now, If you have the same number of protons and electrons, I'll just scan in this picture a wee second. So if the red things there are the protons, you've got 1, 2, 3 protons and 1, 2, 3 electrons. And that means you've got 3 positive charges and 3 negative charges, and they balance each other out. And so we say that that is a neutral atom because the positive charges balance out the number of negative charges. And so we say they balance each other out. So when the number of protons in an atom equals the number of electrons, the atom itself has no overall charge. It is neutral. And you can see the wee scales at the side here. Again, I suppose a kind of analogy where you've got equal numbers of positive and negative charges. I'll just scan in a wee bit to see it. So you've got 9, just in this diagram, you've got 9 positives, 9 negatives, and they balance each other out. So that wee diagram, or those sets of scales, are neutral and they're balanced. Now, in an atom, the electrons can move, but the protons can't. The electrons are found quite far out from the nucleus. The protons are bound really, really, really tightly in the nucleus by very, very strong forces. And it would take a nuclear reaction to remove protons from that nucleus there. So I'll just scan in again. So that's what it would take to move a proton or a positive charge from that nucleus. And so it generally isn't done unless there is a nuclear explosion or a nuclear reaction. So it's only the electrons round the outside, which if you give them a little bit of energy, they can actually move from one atom to another. And once they move, then that kind of destroys the balance of charges in the atom, and then overall it becomes charged. So if you have an atom here, and it loses, say, one of its electrons. So say one of its electrons goes away. It's then left with still 3 protons, but it only has 2 electrons. So in other words, it has more positive charges. Now, 3 protons, which are positive, I'll just put a plus beside it, and only 2 electrons. So it now has more positive charges, which are stuck there, than it has negative charges. So it becomes, overall, it's got an extra positive charge, so it becomes positively charged. However, if you have an atom that gains electrons, so this time if I just say, right, this one here has gained an electron, and I just scan in a wee bit to see, it will now have still 3 protons in the middle, but 4 electrons around the outside. So therefore it has got an extra negative charge, and that means it has an overall charge which is negative. So an atom that gains electrons has got more negative charges than positive charges, and therefore it has got an overall negative charge. So if it loses an electron, it becomes positively charged. If it gains electrons, it becomes negatively charged. Now, to charge an object is actually quite easy. All you have to do is you need some friction between the 2 materials. And so all you need to do is rub one object with another insulating material. So this is just a piece of plastic and maybe a cloth, for example. And when you rub one with the other, then you will have electrons moving from one to the other. Now you can see in this picture, this is the cloth has ended up with negative charges. So it has become negatively charged. You can see they've been drawn on top of this. And that means that the rod, or the piece of plastic here, has lost negative charges. And they've gone onto the cloth, and that means it ends up positively charged. So the rod has got a positive charge. So then also, whenever you charge your object, it then can lift some uncharged objects. Now, in general, those uncharged objects would have to be very, very light. So if you rubbed a ruler and you got the ruler charged, you might be able to lift wee tiny, tiny pieces of paper, but you wouldn't be able to lift big bits of cotton wool or some other insulating material. So, another little point then, once you have two charged objects, what they either do to each other is they either attract each other, so they move towards each other, or repel each other. All the materials, when you did your little test in this, all the materials that did become charged, they're all electrical insulators. So it's only insulators you can charge. And the reason for that is that in an insulating material, any electrons you add to that material or take away from that material, they stay like that, because insulators don't allow charge to flow through them. You can remove and add charge to them, but once the charge is there, it stays until something comes along and discharges it. And that something would have to be a piece of conducting material, like a copper chain or something like that. This means you cannot charge electrical conductors. And the reason for that, electrical conductors are very good conductors because they do allow charge to pass through them. And that's why they are good conductors, but that's why insulators can't, that's why conductors can't allow electrical charge to build up or static charge to build up. They allow charge to go through them, but the charge won't build up on them because they allow the charge to flow away. So you can only charge electrical insulators. So the law of attraction and repulsion, if you have two opposite charges, a plus and a plus, what those two charges will do is they will move towards each other. In other words, they attract. However, if you have two like charges, two negative charges here, then those two negative charges won't like being close to each other and they will move away. So they repel. And again, these would have to be insulating materials, some kind of insulators.